I'm going to introduce David Romano. He is a data scientist with Mediaset. I believe you're located in Milan, so benvenuto.
Thank you.
Yeah, I got a couple more if you want. Come stai? And now I'm out. Actually,
really
now
good.
I'm out. Yeah, bene. All right, thanks so much, David, for joining us. David recently wrote a great article about that was very, very well received about how to monitor a data lake health and status at scale, which he's going to do a presentation on. There's also a repository with a hands-on demo with this, which we'll share also. So yeah, David, I'll let you take it away. Thanks so much.
Perfect. Thank you. So I start sharing my screen.
Yes. Let's see.
Just a second, because I grant information.
Yeah, hopefully you don't crash like I just did at the beginning. I should knock on wood.
Okay. Let's try now. Can you see my screen?
Yep. Perfect. See.
Okay.
Yeah. Nice.
Perfect. So, hello everybody. My name is Davide. I'm a data scientist at Mediaset, and today I would like to share with you our experience, our company experience facing the data quality problem, and how we face the data quality problem with this presentation titled "How to Monitor Data Lake Health Status at Scale: Build a Data Quality Workflow with Great Expectations and Spark." So, before to start and presenting the actual data quality workflow that we built, I would like to present you Mediaset, which is our core business. So Mediaset is the leading private TV publisher in Italy and Spain, with 5 public networks and more than 30 free and paid DIN channels. Mediaset last years decided to invest resources building a data lake to store all the data generated from users' interactions with their devices over the several platforms and services the company offers. So just to frame the situation that we are working with, the current data lake stores every day around 100 gigabytes of data. Inside the data lake, we put several types of data, like clickstreams, page views, video player interactions, and many others. And finally, inside the data lake, we store both raw data and process data. So with the evolution of the data lake and the increasing volume of the data stored inside it and the number of people who daily query the data from the data lake, the necessity to keep the data lake health status under control began to rise. More specifically, we encountered 4 major critical points. So the first one, we would like to verify that the published mobile application, smart TV applications, and web applications are correctly tracking all the events, and therefore all the data stored and correct are trustable. The second point is to extend the ETL pipelines unit test that we are currently implemented. The third one is to monitor that all the pipelines and all the services are up and running correctly. And finally, the last step is to try to detect the data drift or data degradation in datasets involved in our machine learning models. So in order to face the problem, what we implemented is the data quality workflow that I'm showing to you in this slide. So this is an overview of the architecture we implemented, which is composed by 5 main steps: the data quality suite development, the suite deployment, the data quality run, the data validation results analysis, and finally the data documentation. So let's start from the suite development. As I previously mentioned, inside the data lake, we stored both the raw data and the process data. So based on the suite that you want to start to develop, you extract a subset of data that could be raw data or process data, and you import and download it on your local machine. Then you build up your data quality development environment that is based and built on top of a Docker image. In detail, inside the Docker image, we put all the packages that we needed to start to build our expectation suites and our custom expectations. So we use Jupyter Notebook in order to develop our expectation suites. We obviously use Great Expectations, and we also use Spark as execution engine. Docker also supports us during the development of the custom expectations. In fact, you can import the Docker image inside your favorite IDE in order to run and to test your custom expectations running, for example, the function diagnosis. So after you set up your development environment you completed to develop your expectation suites and your custom expectations, you are ready to publish all your material. So what it happens after a commit on the GitHub repository is basically a continuous integration pipeline that we built on AWS Code Pipeline that basically generate again the expectation suites that are contained inside the development environment, just to be sure that all the latest version and the updated version of the expectation suites are compiled and published in the S3 bucket. We also get the Python module that are contained that contains the custom expectations, and we also generate an up-to-date Great Expectations data documentation in a separate S3 bucket. So the next step is the third one, which is the data validation run. Here, it is the core part of the project. In fact, with Amazon EMR that combined with Airflow, which is the data orchestrator we use, we are capable to develop and schedule daily transformations and data quality routines. In fact, Amazon EMR is used on a daily basis for ETL jobs to transform data from raw data to processed data. And we also use it for data quality jobs. As you can see from the plot, we get as input to the EMR job that is in charge to run the data quality jobs. We get as input the raw data or processed data. It depends on the data set you want to evaluate. And we also get as input the expectation suite and the custom expectations that we previously developed and published via continuous integration pipeline. The output of this step is the data quality validation results that natively Great Expectations generate as a JSON file, but we decided to parse and to publish as a Parquet file. This is because the next step, the fourth one, which is the data validation results analysis, starts with the AWS Glue Data Catalog components that crawl the validation results that we previously generated, making the results queryable via Amazon Athena. Amazon Athena is the query engine that we choose to use inside Superset. For those of you who don't know what is Superset, this is an Apache software, so it is open source and free. And its core point, in my opinion, is its simplicity. So given the simplicity Superset provides, we were able to focus on the metrics and on the indexes that we would like to monitor and to control in order to evaluate the quality of our data, rather than building the best dashboard and plot as possible. Another important feature that Superset provides are the alerts and the reports. So in case of the quality alerts, we trigger, the alerts are triggered when an SQL condition is reached, sending a Slack notification to the final user. And also, we use the weekly or monthly quality reports in order to schedule and send to the final user a complete reports that communicates results in a much more organized and clear way. So before to move to the last point, the fifth one, I would like to stop a little bit on the results analysis, and I would like to zoom in this part. So what I would like to share with you is an example of a Superset dashboard that we implemented. What I'm showing to you here is the first two plots that we show in the main dashboard, data quality dashboard that we use. In particular, on the plot on the left, I show you what I'm showing to you is the data volumes, the last month data volumes related to the table we are checking in the example. And on the right, I plot and showed to you a donut. As you can see, in the donut is divided and split into several slices. Each slice represents the property and the platform and the related unsuccessful expectation we want to monitor. Okay, so thanks to EMR and Airflow, indeed, we were able to divide the table that we want to evaluate and to check into several subset of data divided by properties and platforms. This is super useful for the final users. In fact, as you can see from the donuts plot, we can separate our dataset into a list of slices, in this case, which represents the property and the related unsuccessful expectations. Also, on the left one, in the histogram, we show a stack of bars that represents the data volumes for each platform. So also in this case, we can monitor the general data volumes in order to check if everything is okay. But we also check the data volumes for each specific property we decided to monitor. The next plot I want to show you is a tabular one, and this is super important for us. This plot indeed represents the list of the columns and expectations type or expectation name that failed at least for one platform. For example, in the first column and in the first row, we see the column name. So in the first column, we track the principal column, so the subject of the check. In this case, the column that we are checking is named backend app name. The second column shows you the name of the expectations that we ran on the first column name. So the expectation in this case is named expect multi-column backend app name composition. So in this case, we are checking that the custom expectation multi-column backend app name composition is running correctly on the column backend app name. The third column represents what we called a complementary column set. So complementary columns in this case is a list of all the columns that we use to evaluate the quality of the principal one. So in this case, in backend app name column case, we used channel, bit platform, OS version, and play request ID to evaluate the quality of the backend column. But a little note here, in this case, in the complementary column, we don't actually use all the columns that we list here to evaluate the quality of the principal one, but in fact, we add new complementary columns in the list based on what we need to see in the partial unexpected list. And we saw further information on the next slide. Finally, the last column represents the number of the properties and the platforms that where the expectation and the column failed at least once. And in this case, it counts the number of platforms that failed. So in this case, the backend app name, the check expect multi-column backend app name composition for the column backend app name failed for 10 platforms. So given the previous tables that I showed to you, it allows to the final users to filter the rest of the dashboard. And in this case, I show you what happens to the next plots if the users selected the pair column backend app name and the check expect multi-column backend app name composition, what we basically showed and so on the previous slide. So what I'm showing to you is that the first plot is a line plot that represents the percentage of unsuccessful records divided by each platform that we that we are tracking in the current dashboard for the current expectation suites for the last month. So this is super powerful because basically it allows you to keep track of trending, how consistent is the error during the time, and it basically helps you to see if there is somebody happens an unexpected spike on your data. So this is a super easy and super powerful tool to visualize how good your data is during a precise amount of time. So in this case, the last month. Finally, the last plot is the partial expected list that, as you previously mentioned, given the period of time that we are working with. So here I'm showing to you the singular date time, and also divided by the platforms and the properties that we use to divide our table data. We show in a traditional format that Great Expectations provides, so a list of dictionaries, the list of the columns that we previously show. So as I previously mentioned, we are checking the big up name, but we also use as a complementary columns the list that I provisioned to you inside the table that I previously showed. So here we list all the columns that we use in the selected expectation. And as I previously mentioned, we also selected a column named Play Request ID. This column, this specific column, is not useful for the check. We didn't use this column in order to evaluate in a better way the primary column, the backend app name, but we inserted it as a complementary column in order to copy paste the content of the column and allows to the final users to use this string to continue to analyze data in Athena, in Spark, or in a subset in Pandas. And this is, in my opinion, is a super powerful feature that we provide to the final users that can use not just the output of the Great Expectations, but also other features that it can use, get and use in other platforms. So back to the data quality workflow. The last step, the fifth one, is the data documentation. This step is in charge to publish the data documentation website that we previously generated with a Great Expectation, and we moved to S3 bucket with a continuous integration pipeline. And just to conclude, the data docs is the last step, but not for importance. In fact, in our case, the data docs allows us to share the expectations logic with the non-technical people, making it easier to discuss possible and future suites announcements. So before to conclude, I would like also to show to you a bonus slide. I call it bonus because on the article that we published, we didn't mention anything about it, but people on Great Expectations Slack channel and people inside Mediaset company asked me some interesting question, and we already tried to face the problem that I mentioned. So here I report 3 top questions that I think is super interesting, which are: who is the developer of the expectations? Data engineers or analysts with some technical background? How do you know what to expect from the data if you are not a domain expert? And how to make the data quality workflow accessible to non-technical domain experts? So we tried to answer those questions implementing a process that we called data quality evaluation process. So the process is composed by 5 steps. The first one is called the suite design. So during this step, domain expert is in charge to design the expectation suite. But the expectation suite in this phase is just a design. So what we expect is to have or to compile a requirements document, which is wrote in natural language, that represents, like in software development, the information about the table that you want to cover with an expectation suite. So the list of the columns and what you expect to achieve from each column. Who is in charge to compile the requirements document? Basically, the domain expert. So it is the case maybe that you want to evaluate the quality of the data in a table that is used on a business intelligence layer, then maybe the domain expert should be a business analyst. Or if you want to evaluate a table that is the output of a transformation process, maybe it could be the case that the domain expert in that case is the ETL developer or the data engineer. So what we expect to generate from this step is a requirements document that collects a sort of rule of thumbs of what you expect from your data in natural language. So the next step is called requirements review. So here, great expectations experts, so people who actually know how to develop expectation suites and custom expectations, that could be data quality team or maybe just a developer, have to review the previously wrote requirements document, and it has to answer the question, are the requirements clear enough? If the answer is no, then you have to look back the document and you have to cycle inside this loop at least until you reach the answer yes to the question, are the requirements clear enough? Then, once the requirements are clear enough, you arrive at the third step, the suite development and scheduled run, which is basically the steps that we previously saw in the data quality workflow. But please notice a thing. Here, thanks to the steps number 1 and number 2, basically we reached a complete and exhaustive requirements document, which was compiled by a domain expert. So inside the document are listed all the information and all the requirements that a domain expert knows and expect from the data. And it is also reviewed. It was also reviewed by a great expectation expert. So a man who is in charge or is able to break down an expectation suite. So basically, starting from step number 3, people have just to write down code to evaluate the data related to the requirements document. So in the step number 3, we develop the suite, we schedule and run the data quality jobs, and then we arrive at the step number 4. So inside Superset, we run validation analysis. Finally, the last step is the actual data quality evaluation that we call data health status. Please note that this is a vertical drill down. So this is a view of a singular table, but if you replicate this process for several tables, specifically for all your tables contained into your data lake covering your tech debt, basically what you achieve on the step number 5 is not just the data health status, but the data lake health status. So just to wrap up and complete the presentation, I would like to present you some reference and useful links, as Kyle previously mentioned. The presentation is based on the article that we published on Towards Data Science. I leave here the link. And we also provide a companion GitHub repository that is public, in my opinion. Inside this repository, you can find a lot of useful information if you have just started to play and to work with Great Expectations. We try to insert inside it whatever we know and we understand from the package. We try to document everything with readmes, docstrings. We implemented examples of single, pair column and multi-column custom expectations, unit tests with diagnosis. We also included Makefiles, Docker files, whatever you need to start to work with Great Expectations and Spark. That's it. Hope you enjoyed. Thank you.
That was awesome. Thank you, Davide. That was excellent. I love that bonus slide. Really, really, really good stuff. I mean, it's definitely, how we imagine working with other stakeholders, and it's great to share. It's great to share that with other data engineers to help, get other people on board with why great expectations is important and how it works with your other team.
Yeah,
Does
thank you.
does anybody have any questions?
I had one. Just wondering about the selection process that you use for generating the samples that you use for creating the suites. Because is it like a random sample, or you use like recent data? How do you decide what to do there?
Yeah, right now we just get a random sample. This works good enough right now. We don't use a specific approach to get the subset just to generate the expectation suite, because what we expect is that this is indeed a sample that should statistically represent the final results. But as I previously mentioned, we work with a huge amount of data, and the properties constantly evolves and change during the time. So it could be maybe the case that during the months or years, we constantly evolve and update our suite and our custom expectations logics.
Oh, that makes perfect sense. Thanks.
You're welcome.
Any other questions?
Yeah, I had, oh, okay. So have you found that the first two steps in your data quality pipeline have gone, one, how did they go at first? Did it take like a lot of revision cycles to move on to step 3? And then have you seen those teams be able to work more efficiently together as they've done more and more requirements together? Or is it still?
You mean the process, the data quality evaluation process?
Yeah, steps 1 and 2 in that slide.
Okay, so yeah, the loop is not easy, especially if you work with a domain expert, which is a non-technical person. You for sure know that Great Expectation is easy to use, yes, but inside Great Expectations, there are a lot of concepts and information that a technical person knows, and it tries to traduce the knowledge and information and the feature that Great Expectations provide to natural language and to some rules that he has to share with the domain expert, especially with the non-technical domain expert. So it is not an easy step, but I'm assuring you that if you can use a requirements document in order to build your expectation suite, the third step is super easy and super straightforward, because basically you arrive at the third step with a clear requirements document that may be in order to be achieved and to be closed and to be good enough to be developed, you have to work with the domain expert for at least, I don't know, 1 week or 2 weeks. But once you get the requirements document, you just have to code whatever is brought down inside the document. So in my opinion, this process right now is super useful. Based on my previous experience, when we didn't use this process, we basically started developing the expectation suites, but as we are maybe not domain experts of that specific table and the specific business logic contained inside that table, we started to ask people to constantly make phone calls to other people to ask, hey, I don't know, Marco, you know what's inside this table? You know what is the logic behind this column? Basically, because besides the basic check that you have to implement, like column is not null or it is a string or stuff like that, if you have to check specific logic, but especially business logic behind a specific column, it's quite hard to understand what is the logic behind it if you don't work with the domain experts. And working with the requirements document is the perfect standard that allows you to speak with the non-technical people. So this is the first question. Sorry, you had also a second question, right?
I was just wondering if the process of getting the requirements document sorted out has gotten any smoother as time goes on, or if it's still early enough that it's kind of new to everyone, especially the domain experts, and working with the GX people and getting that sorted out.
So, sorry, you asked me if the document is fine also for people who don't know GX.
If the process of coming up with the requirements document is getting easier for people as time goes on, or if it has not really, you haven't really done enough yet to see if that's been the case.
No, we already applied it. So all the all the tables we covered with expectation suites have been covered with this loop, with this process. So right now, I think that it can work in our company. And so the review process, in my opinion, can fit our necessity right now.
Hey, David, this is great. Quick question also about this bonus slide here. How, especially to kind of get the company aligned on the process around step 1 and step 2, like how long do you think like that took, and what was like your biggest challenge to kind of getting company aligned around that, around this process?
For sure, the biggest problem here is to try to explain to the problem is in our case are represented by non-technical people. So the problem is to speak and to work with non-technical people, especially if people are super busy on their daily job, and you submit to this non-technical people requirements document, and you ask him, hey, can you help me to provide some information on what kind of check you want to achieve on this specific table? But once you well documented the entire process, and you make sure and you share with the non-technical people that the process, once you achieve a complete and exhaustive requirements document, non-technical people and domain experts works fine and happily on the requirements document. I know that the requirements document is a boring job. It's not super funny, but if you know to evaluate the quality of your data, and you want to assure that the data you are using on a daily task, then this is the job you have to accomplish. So this is how we work right now.
Gotcha. Yeah. So sorry, I know we're out of time, but just maybe a bit, if you can elaborate on like the kind of maybe the pushback from the non-technical folks. Is it they don't see the value of the process in general, or is it like they have trouble like articulating the requirements? What was like a specific hurdle there?
No, maybe Dan. They don't see the value. If they don't see the value, they basically don't want even to start to work and to write on the requirements document. But if you start working on the requirements document, and the document move to the second step, the requirements review, and the documents go back to the domain expert, then it means maybe that the document is too superficial. So the non-technical domain expert works on a too high level, and maybe during the suite design review, the technical people saw and found some mistake or some open points that it could be the case to be explored and to be much more clear in order to implement the best expectation suite as possible.
Gotcha. Okay. Yeah. Hey, thank you so much. This is great.
All right. That about does it. Right on time at 1 o'clock my time. I know it's a little bit later for some people or earlier. Anyways, thanks so much everyone for coming. Thanks Davide for the presentation. That was amazing.
Thank you.
Go check out the resources that I gave for his link. to the blog and to the repo. I'll make sure to have that stuff in Slack, and I'll also add this recording into Slack in the next couple days. All right, everyone, I'll see you next month.
Thank you.
Thanks,
Bye-bye.
everybody.
Thanks,
Thank you very
Thanks,
much.
everybody.
Bye.
Thank you all. See ya.